So today we're talking about proportions and similar figures. Right here we can see triangle ABC is similar to triangle FGH. This is a symbol for similar. Similar figures have the same shape but not necessarily the same size. So if we look at these two triangles, they have the exact same shape, but their size is different. Okay. Now, similar corresponding angles of similar figures are congruent. This is a symbol for congruent, and that means that they're equal. So that means that angle A is equal to angle F, and angle B is equal to angle G, angle C is equal to angle H. Now if I take these triangles and I place them one over the other, can you see how angle A and F measure exactly the same? If I move it to angle B and G, can you see how they measure exactly the same? Same thing for angles C and H. So that's one of the properties of similar figures. Now just to show you, let's say we have these two parallelograms. Okay? Are these similar? Same shape, different size. Now the corresponding angle would be this one with this one. This one with this one. This one with this one, this one with this one. So if I place one over the other, can you see how they have congruent angles? Yes. Congruent corresponding angles. Corresponding meaning that they're in the same relative position. If I move it, see how the angles are equal. Same thing here. Let's say I show you two squares. Are these squares similar? Same shape, different size. Their corresponding angles will be the same size. Now we know that all squares have all 90-degree angles, right? So, because it's a square, either way they would be equal. But can you see that? Okay. Now when we see triangle ABC is similar to triangle FGH, that tells me A corresponds to F. They're in the same relative position. B corresponds to G. They're in the same relative position. And C corresponds to H. They're in the same relative positions. We talked about the corresponding angles. Now the corresponding sides are in proportion. So let's look at that. We have the big triangle to the small triangle, or we can say figure 1 to figure 2. So if we create a proportion of the corresponding sides, and we have side AB corresponds to side FG. Yes, ma'am. Yes, you may. Side AB corresponds to side FG. They're in the same relative position. Do you see that? Okay. So if we say AB corresponds to FG, that means that that proportion should be equal to AC and FH. So let's try that. AB measures 12, FG measures 8, and that should equal to AC, which measures 15, and FH, which measures 10. So we did figure 1 to figure 2, right? Figure 1 to figure 2. If we simplify 8 to 12, this means 3 to 2. And if we simplify this, we get 3 to 2. Do you see how they're proportioned? Now we're missing a side. We could say that this should also equal BC and GH. And let's try that. BC is 18, GH is 12. This simplifies to 3 over 2. Do you see how their proportion is equal? Yes, sir. So my figure is not drawn to scale. I drew it. I didn't measure it. So without guiding our eyes by the sizes we see, that's why I say not drawn to scale. If we have triangle ABC is similar to triangle DFE. By the letters here, I know that angle A corresponds to angle D, angle B to angle F, and angle C to angle E. Now we have 3 measurements on one triangle, on the big one, and I'm going to call it figure 1. And we only have 1 measurement on figure 2. If we need to find DE, what would we say? Well, we know that AC corresponds to DE. AC corresponds to DE. They're in the same relative position. And I'm doing figure 1 over figure 2. I also know that AB corresponds to DF. And I know that similar figures, their corresponding sides are proportional, right? Yes. So, can I find a missing side? Okay, so AC is 21, and that corresponds to DE, which is X. AB is 15, and that corresponds to DF, which is 10. Can I solve my proportion to find my missing side? So 10 times 21 is equal to 15x. 210 is equal to 15x. We can divide both sides by 15. And what do we get? X is equal to 14. That means that this missing side is 14. Can we find EF? Can we find EF? And let's call it Y. Yes. Okay. So what can we do? Okay. So CB corresponds to EF and AB corresponds to DF. So if CB is 18, EF is Y, that's what we're looking for. AB is 15 and DF is 10. So we can do the same. 18 times 10 is equal to 15Y. So 180 is equal to 15Y. We can divide both sides by 15. What do we get? 15 times 12. 12 times 5 is 10. So Y is equal to 12. That means this side is equal to 12. Now, the reason we can do this is because we know the facts about similar figures. Yes or no?